talk about how to multiply when we have exponents. So what if we have this one? Let's look for a trend. 6 to the 4th times 6 to the 5th. So your answer here is simply going to be, we have 6 times 6 times 6 times 6. There's your 6 to the 4th times 6 to the 5th. So 6 times 6 times 6 times 6 times 6. How many 6's do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Your answer comes out to be 6 to the 9th. Let's look at another one. See if you see what's happening. We have e to the 5th, e times e times e times e times e times one more e. This time our answer comes out to be e to the 6th. Are you seeing a trend yet? Because I'm sure not writing out f 125 times. So here's what happens. Notice up here I had 6 to the 4th and 6 to the 5th. My answer became to the 9th. 4 plus 5 gives us 9. Here I had e to the 5th plus one more e, which sometimes we would say this would be e to the 1. My answer here came out to be e to the 6th. So watch what's going to happen here. I have f to the 6th plus f to the 7th plus f to the 125th. My answer, when I multiply f to the 6th times f to the 7th times f to the 125th, is f to the 138. So what is the rule you need to know when you multiply with exponents? The rule is that to multiply numbers or variables that are raised to a power or have an exponent, you're going to add the exponents of the numbers or variables with the same base. This rule only works if the bases are the same. So it worked because both bases were 6. Here it worked because they were both e. Here it worked because they were all f. If I had tried to add e to the 5th and f to the 6th, or multiply them, I should say, my rule doesn't work. Let's look at some examples. Okay. So here we have 3 times 3 to the 3rd. Remember, this is really 3 to the 1. When nothing's written, you can assume a 1. So we're saying 3 to the 1 plus 3. So this is 3 to the 4th, which we could actually multiply out. 3 times 3 is 9, times 3 is 27. 27 times 3 is 81. So 3 to the 4th, or 81. Okay, what about over here? I have m to the 5 plus 7 plus, 87. Thank goodness for the rule, because I would not want to have to write out m 87 times. So 5 plus 7 gives us 12. 12 plus 87. This one becomes m to the 99th. Okay. Obviously, I can't simplify it like I did this one because we're dealing with a variable and not a number. Okay, so what happens here? I have a to the 5th plus, remember this is a 1, a to the 1, b squared. What do I do with it? Let's hold on a second. Plus a to the 11th. Now my b squared, because it has a different base, I have to leave it alone. So my answer here actually becomes a to the 6 plus 11 is 17. A to the 17 times b squared. We just leave it alone. Let's look at another one like that. I have x squared, y to the 4th, x cubed, and y to the, remember, imaginary 1. So I would combine the 2 and the 3, and then I can combine the 4 and the 1, so that my final answer here becomes x to the 5th, y to the 5th. Okay, let's look at a couple more. In this one, I didn't use the dots for multiplication. I used parentheses, but in this case, parentheses just means multiply. So I have 3 squared, 3 to the 1, times, different base, 2 to the 3rd. So I get an answer of 3 cubed times 2 cubed. Now, this one's numbers. I can multiply it out. 3 cubed is 27. 2 cubed is 8. I don't actually know what 27 times 8 is, but I bet you can figure it out. We did it 27 times 8. $216. So for this one, we are able to simplify it all the way till we have one number. Okay? One more. We have c to the 4th, d to the 7th, c to the 17th. 2 common bases, so 4 plus 17 gives us c to the 21. We leave the d alone. Okay, so this is multiplying numbers or variables with exponents. So now, let's add another layer. What happens if there are coefficients? What is a coefficient? A coefficient is this number right in front. You know this is the base and this is your exponent. This number in front is a coefficient. So here we have 6 as a coefficient, 3 as a coefficient, and 2. We have 3 coefficients. Well, if there's coefficients, you multiply them. So in this case, I'm going to do 6 times 3 times 2. So 6 times 3 is 18. We'll do 6 times 3 times 2. And then I've got A. They all have the same base. 3 plus 1 plus 5. So 6 times 3 is 18. Times 2 is 36. A. 3 plus 1 is 4 plus 5. 36a to the 9th. Okay, let's do a few more with a coefficient in front of it. Here, once again, I have my 6 times 3 times 2. Then I have y to the 2nd, y to the 3rd, and y to the 4th. So I have 36, y, 5 plus 4 is 9. Okay, what about this one? This 7 has an x with it. So in this example, I cannot use the 7x squared when I deal with the 2y cubed and the 2y to the 4th. I can do my 2 times 2, the coefficients that are with the y's. Then I'm going to do my y, 3 plus 4. And this is going to stand alone, so I'm just going to multiply it by 7x squared. So my final answer is 2 times 2, or 4y, 3 plus 4 gave us 7 times 7x squared. Kind of running out of space. All right, let's look at one more. I have 5m, 2p to the 4th, and 3m to the 8th. So once again, I have one where the base doesn't match, so I cannot combine it with the other ones. But I'm going to put it first. So 2p to the 4th is going to stay 2p to the 4th. Now, I can do 5 times 3. 5 times 3. M is going to be, remember, 1 plus 8. So now my answer becomes 2p to the 4th times 5 times 3 gives us 15, m to the 9th. So we have 2 things we need to remember when we're dealing with multiplication of exponents. One, if they have the same base, you simply add the exponents. But if their bases are different, you cannot add the exponents. The other thing you need to remember is that when you bring a coefficient into play, you can multiply those coefficients out in front.